Yeah. Hi everyone, my name is Balaji. Currently, I'm pursuing my BTech in Computer Science and Engineering with the specialization of Artificial Intelligence and Machine Learning in the institution called Institute of Aeronautical Engineering, Dundigal, Hyderabad. And today, as per my topic of AIT to TED Talks in the subject Object-Oriented Programming, my project is about making a solution for Sudoku solver using object-oriented programming through Java. And here we are diving into the solution and introduction to this Sudoku solver. First of all, we have to know about what is Sudoku. And Sudoku is a 9 by 9 grid puzzle that requires so much of logical thinking. And the goal to finish this game is fill each row and each column and a 3 by 3 box with digits 1 to 9. The Sudoku solver uses object-oriented programming plus backtracking algorithms. It demonstrates the power of abstraction, modularity, and classes. Here, whenever a person tries to solve the Sudoku, he have to put his all all out of the effort to fill it because it may be clumsy, it may be whatever it may be. It should be the number of digits in a row or column or in the box should not be repeated. That becomes a bigger task to the users or solvers to solve this, and we are getting into the solution for this. With diving in deeper into this, we can know about this. Why use of object-oriented programming for a Sudoku solver? What object-oriented programming does is makes code modular and easy to maintain. It makes the code look modular, and also classes represent a Sudoku board, a validator, a solver, and increases reusability and encapsulations in the programmings. And it was also a good example of object-oriented programming applied to real-world programs like no, using of encapsulation. You can override a method as many times you wanted, and I also you can also validate how much information you wanted from the Sudoku solutions or etc. whatever you want. And also modularity means it divides the main system of problem into modules, and it gives the answer for it, and you can be able to make it clearer soon. And diving to next topic, the object-oriented concepts used. What are the concepts we have used from object-oriented programming to solve this Sudoku solver solution? I have used classes and object, which represent puzzle board, and also encapsulation, which hides data, both stored in class. Also abstraction, which solves a hide internal logic. What is the logic needed to solve this? Which it hides it. And also modularity. It functions for checking rows, columns, and boxes. And also recursion as a backtracking algorithm. Recently, we were learning it from our labs, and also the recursion method mainly helps in overriding instead of overriding when backtrack the methods and algorithm is easy, and it makes your work less burdenable. And coming to the next one, you can see backtracking algorithms. Backtracking algorithm means how backtracking algorithm works means first you have to guess a number or think a number logically, which can be fit into the certain spot, and uh, answer it when you when you enter that digit in it, placing the number 1 to 9 in the empty cells, whichever maybe in row or column in the empty cells. It checks if the placement is valid or not. If it is valid, it will move to the next cell. If it is invalid, background it will give the output as try next number. Means that means your input and the modularity which has been hidden should be matched with one each other. Then only it can be moved to the next cell. And it continues until the entire puzzle is solved. This is how it works. And coming to this validation logic. What is the logic we needed for Sudoku is the number is valid. not present in the same row and also not present in the column row, and also it should be not present in the 3 by 3 box. It should be the unique number which in row, in column and the 3 by 3 box. Then only here in the image you can look that here in the first image they have given already 3, 8 and 2. Here they inserted all of 5 in the second row first column. That means the 5 you can check it is not in any column and it is also not in any row and it also not a 3 by box. Here you can see a 5 but it is not in the same box but it is in the second box. This is the logic what we needed to solve this Sudoku solver problems like this, how you solve this problem is the main logic what you think and what you perform there. And coming to the next one, class design. What is the design for the class we have given values? How much structurally we kept the classes here is we first created a Sudoku board, a class called Sudoku board, which contains the regular attributes of a Sudoku solver, which should have a square shape board, 9 by 9 grids. This one, and what it shows stores the grids, columns or rows, it stores the grids and displays the board. Like if you want a chessboard, you can create a class called chessboard and you can give the attributes to it, and also you can have to create a class called Sudoku solver because we are solving the Sudoku here. We have to use some methods called valid or empty cell and solve methods which you have to use also recursive backtracking so that it is valid, yes, find empty cell, yes, solve or recursive backtracking, yes. In this way you can mold your classes into your attributes and your gaming system. And here you can see the flowchart for the main code or the source code for this Sudoku solver. And it is start the game, find the empty cell, no puzzle solved still, try digits 1 to 9. If it is valid, no, try next number, place number, recursive solve because what happens if you recursive solve means it again goes to is valid. Again recursion goes to is valid. Again recursion goes to is valid. If it fails, it will reset all the cells and backtrack again to the recursive method. That means this loop continues endlessly within it, and it mostly gives perfect outputs. I make sure that the code gives perfect outputs, and I have been testing this code since 3 days and I have succeeded in this code, and this is the flowchart of this code. That is what I can give to you information about the code. And mm, coming to advantages, what are the advantages of using object-oriented programming in this Sudoku solver means uses clean object-oriented structures as we discussed in classes or recursive methods or whatever the methods we needed. And also coming to here, it is also efficient for solving complex puzzles. Not only Sudoku, but also chess or Chinese checkers or whatever the board games you have. The correct logic and correct thinking of the code and correct structurable payment of the code may clear even complex puzzles also. And also real world algorithmic applications can be solved by using these codes, or new applications can be developed. And also good demonstration of recursion and logic has been happened in I think in this side also you have been knowing it about more and more. And also yeah, coming to the conclusion, I want to conclude like a Sudoku solver showcases a strong object-oriented programming according to my point of view. And also, backtracking algorithm ensures complete search, combines computational thinking plus object-oriented approaches wherever wanted. And what happened? Why I chose object-oriented programming in this Sudoku solver because the first main reason is we have been working on object-oriented programming in the part of Java in our college till the last 3 months or for last 3 months or from the college of start of the college. And I have been observing my friends who are learning Python or C++ or C Sharp from outside institutions. I think it was way too easier and which was also platform independent and also uh, I was a little bit faster than them, little bit ahead from them. So I chose object-oriented programming as well as I know the basic syntax of Java. I could do it. So I prefer object-oriented programming for the future uses like anything you use it for applications, real world algorithmic solutions to solve a Sudoku solver, chess solver, carom solver, whatever you need. Any complex problems, whatever you can be done with the real algorithmic expressions, you can use object oriented programming. Yes. Um, Thank you for paying attention for this much. Thank you. You are obediently Balaji. Thank you, everyone.